Hey kiddos, hope that you had a really good weekend. Here we are going to talk about X and Y intercepts. X and Y intercepts are points on the graph, and they always have some sort of meaning, and they're very important when we are talking about slope and the graphs of linear functions. So the x-intercept, which is also sometimes called the zero of a function because it's the point where y equals 0, is the point where a graph either crosses or intersects the x-axis. And since that's where it goes across the x-axis, that's why it's where y equals 0. The y-intercept is the other of the two intercepts we'll talk about, and it's the point where a graph crosses or intersects the y-axis. It does not have a special name. It's just the y-intercept. So let's talk about finding them. If you were given a graph, okay, a graph of any function, we're just going to talk linear functions now, but if you're given the graph of any function, find the x and the y-intercept. You just got to find where it crosses the x and the y-axis. So let's do the x-intercept first. The x-intercept for this first graph is where this graph crosses the x-axis, which is right here. That point as an ordered pair is 3, 0, because we went over 3 but not up or down at all. The y-intercept is the point where it crosses the y-axis, which is this point right here, and its ordered pair is 0, 3. Because I didn't go right or left at all, and then I went up 3. So there it is. Now let's just find the slope just for the sake of having the slope. We can point down. These are two very pretty points, and so we'll just count our rise over our run. We go down 1, 2, 3, and over 1, 2, 3. So the slope is negative 3 over 3, which is just negative 1. And so there's the slope. That's going to be important. It's always important to go ahead and find the slope, but you have your slope and your y-intercept and your x-intercept. Our next graph is a vertical line. It is not a function, but it still does have intercepts. This only has one intercept, however. It has an x-intercept because it crosses the x-axis. It crosses the x-axis right here, and we're going to estimate that that is 3.5 because it's in the middle of 3 and 4. So we're going to call that 3.5 and 0. The y-intercept of this graph, however, it never crosses the y-axis, and it is never going to cross the y-axis because it's vertical, so it's parallel to it. So it has none. Unless a vertical line is directly on the y-axis, and even then it doesn't have an intercept, it just crosses it everywhere, your y-intercept is going to be none. Now the slope of this line, it's important that we go ahead and write this down since this is a vertical line. If you will remember, Vux, okay, vertical lines have what we call undefined slope. So the slope of that is undefined. So that's how you find it from a graph. You just, where does it cross the x-axis? Where does it cross the y-axis? So now let's find it from a table. If you will go back to what we just did from the graph, I have x-intercepts and y-intercept. If you will notice that the x-intercept, the y value is 0, and at the y-intercept, the x value is 0, and that will always be true. So the x-intercept is where y equals 0, and the y-intercept is where x equals 0, which is just the opposite. And so to find my x and y-intercept from a table, this number, it's not really number 5. I don't know why my numbering is all off, but you have this pretty little table here. Here is where y equals 0, and here is where x equals 0. These are going to be your two intercepts. Because this one, where y equals 0, I have a value for x, my x-intercept is this one. My y-intercept, because x is 0, but I have a value for y, is this one. So here's my x-intercept, and here's my y-intercept. So my x-intercept is negative 3, 0. My y-intercept is 0, 5. It also asks for the slope, so I get to do that change in y over change in x stuff from, that we learned several days ago. It's crazy that we're going to use stuff again that we've already learned. But I'm going to use these 2 points because they're right next to each other and they're positive. I don't have to deal with a whole bunch of negatives. So my change from here to here is plus 5. And my change from here to here is plus 3. That makes my slope 5 over 3. So for every change of 5 on the y-axis, I change by 3 on the x-axis. And so there's my slope. Excuse me. So let's do the next one. You have another table here. Here's where x equals 0. and here's where y equals 0. So my x-intercept is where y equals 0 because I have an x value there. So this is going to be 9, 0. The other point where I had a 0, this is going to be my y-intercept because y has a value, and so my y-intercept is 0, 6. Now the slope of this line, change in y over change in x, my change from here to here is minus 2. My change from here to here is 3. So the slope of my line is negative 2 over 3. This is a decreasing line. It's going to go down from left to right. Now if you'll look at the very next one, look at the table, the values in my table. These values in my table, I don't have any zeros. They don't exist. They're not there. And so the first thing that I really need to do is I need to sort of figure out what my slope is. It should help so that I can use the pattern to walk through the table so I can find my zeros, because I need the point where x is 0 and I also need the point where y is 0. So let's find our slope. Even though it doesn't ask for it here, let's go ahead and find our slope. So my change in my y values right here is plus 2. My change in my x values right here is plus 6. So my slope is 2 over 6, not 3, which is the same thing as 1/3. So every time my y changes by 1, my x changes by 3. So that's going to be important. The point where y equals 0 is going to be in here somewhere, okay? It's going to be right before this one. And so I can use my slope to get there. If I go from here to here, that is a change of 1 in my y value, which is what I have for my slope. But this right here needs to be a change of 3. So I need to have a change from here to here needs to be a change of 3. Well, so 9 plus 3 gives me 12, and that makes it negative, which is not what we want. So hang on, I have to go back. So back to this. Here's my change of my slope. This needs to increase by 1, and this needs to increase by 3. So I had it correct here. From here to here is an increase of 1. But from here to here, whatever this number is, I need it to be an increase of 3. So something plus 3 has to equal 9. That something is 6. So here is my first value where I have a 0. And since the y is 0, that means it's my x-intercept. So my x-intercept is 6, 0. Now I also need to get my y-intercept. So I need my x value to be 0. Since I know that I want my change to be a change of 3, okay, I've got to figure out where 0 is. And I know that my 0 is going to be in here somewhere. X is going to be 0 somewhere between negative 3 and positive 6. That's where it gets fun. I didn't leave myself a lot of room to write here. But somewhere between negative 3 and positive 6, I'm going to have to equal 0. And so I have my change in y over my change in x. My x values need to increase by 3. Well, negative 3 plus 3, I'm going to have to write really small, is 0. Because negative 3 plus 3 gives me 0. So there's where my x value equals 0. That means this change here has to be an increase of 1. So negative 3 plus 1 gives me negative 2. So my y-intercept is 0, negative 2. And I'm not sure that I did that in the most elegant way possible. So I'm going to do another one and see if maybe it's less confusing. So here's our other table, and we're going to do the same thing. We're going to find our slope first because it will be important to know our slope. It will help us to find our table of values, or use our table of values. I'm going to use my positives. From here to here is a change of 10. From here to here is a change of 4. So my slope is 10 over 4, which simplifies down to 5 over 2. So every time these increase by 5, these increase by 2. So I know I need to have an increase of 5. And if I look at my table of values, y is going to equal 0 somewhere between here and here. X is also going to equal 0 somewhere between here and here. So let's do both of them. Let's find where y equals 0 first. I know that my y values have to change by plus 5. So if I start here and go to the next one and I go plus 5, well, negative 5 plus 5 is 0. So there's where my y equals 0. This needs to be a plus 2. So negative 4 plus 2 is negative 2. So my x-intercept, the point where y equals 0, is going to be negative 2, 0. Now from there, I know that somewhere between here and here X is going to equal zeros because it went from negative to positive. My signs changed. So I'm going to go backwards this time. My X values are on the bottom, and they have to be plus 2. So from here to here, I have to change plus 2. So negative 2 plus 2 gives me my 0 for my y-intercept. But this also has to increase by 5 because my y values up here on my slope are plus 5. So 0 plus 5 is 5. So my y-intercept, the point where x equals 0, is going to be 0, 5. So if they do not give it to you specifically in the table, you will have to use your slope to try and find it. Okay, now let's look at a real-world graph and see if we can't determine the meaning of our x and y intercepts. So here's what we have. The volleyball team is traveling to a game that is 120 miles away. Their average speed is 40 miles an hour. This graphed line describes the distance left to travel at any time during the trip. We just want to find the x and y intercepts and state what they represent. So let's do the x-intercept first. The x-intercept is right here, and at that point is going to be 3, 0. And if you look at what is graphed on the x-axis there, that is the time. Now this graph is how much distance is left remaining, okay? So the distance left remaining is the y value. So this is where they have no distance left remaining. This is their time. So this x-intercept here is the time it took for them to reach their destination. So this x-intercept tells us that it took them 3 hours, that's a t, to reach their destination. We'll just say to reach the game. So it took them 3 hours to go 120 miles. The y-intercept, let's find it. It's this point right here. Well, it's at 0 and 120. Well, the 0 here is the time because that's the x value. The y, the 120, is our distance. The 120 is where they started. They started 120 miles away. So this is their starting point. So at time 0, they were at 120 miles away. That is their starting point. So that is what your x and y intercept mean, and you're going to have to spend some time with that. Now, if you were going to find slope, I know that this question is not on here, but this is a question that we have struggled with, so let's go ahead and do it. Here is a pretty point, and here is a pretty point. So let's find the slope of our line, and each one of these is a value of 10. So this goes down 10, 20, 30, 40, and over 1. So it goes down 40 and over 1. And if what I want to talk about, what does this mean? This is their miles traveled per hour. So this is miles over hours. The negative only gives me direction. It tells me that they are getting closer to their destination. Their distance is decreasing, but that is 40 over 1, miles over hours. This is their speed. So their slope is their speed. They are traveling 40 miles an hour. 2 more questions. Sometimes instead of giving a graph or a table, you were handed an equation, and it says find the x and the y-intercept. Here's the thing that you need to know. The x-intercept is y equals 0, and the y-intercept is where x equals 0. That will be really important when you have an equation because you've got 2 variables here. And since you have 2 variables, you've got to be able to do something with one of them, know something about one of them to solve. So if I want to find the x-intercept, that's where the point where y equals 0. So that means I get to plug 0 into here. Well, if I plug 0 into this, 2 times 0 just still equals 0, so this just cancels out. So if I want the x-intercept, I can pretend like this isn't here, and I can solve this equation because that's going to cancel when I plug in the 0. So I can solve this right here for x. And to do that, I can multiply by 2 on both sides to get rid of that denominator in the fraction. That leaves me with 1x, or just x. And then negative 4 times 2 is negative 8. So my x-intercept is negative 8, but I need it as an ordered pair because it is a point on the graph. So it is at negative 8, 0. If I want the y-intercept, same thing, except the y-intercept is where x equals 0. So I would plug 0 in for the x value. But if I plug 0 into here, 1/2 times 0 is 0, so this is just going to cancel out, leaving me only this. So I would have negative 2y equals negative 4. And I can solve that for y by dividing both sides by negative 2, and you get that y is 2. So my y-intercept is at 0, 2. So one more. This one has variables on both sides. You've got a negative 2y here and a y here. So let's put them together. Let's add 2y here and 2y here. So my y's are all together. So I have x equals 3y minus 3. So let's do the x-intercept first. That's where y equals 0. So that means this is going to be canceled out, because when I plug in 0, it just cancels out. So I am left with x equals negative 3. Didn't have to do anything at all. My ordered pair for my x-intercept is negative 3, 0. If I want the y-intercept, so I want the point where x equals 0. If I cross this out, there is nothing left over here. So I'm going to go ahead and substitute in, because this is all by itself. So if I want the y-intercept, I want the point where x is 0, so I want this. The only time you don't just cross it out is when that variable is alone. So now I'm going to solve for y. I will add 3. So I have 3 equals 3y, and then I will divide by 3, and I get that 1 equals y. So my y-intercept is where y equals 1, so it's at 0, 1. There are your two ordered pairs. So that is X and Y intercepts. I will see you guys tomorrow. Have a great day.